Okay class, I just wanted to do a quick video today in a couple of parts to help you with your truth table homework. So what I have on the board here are just some of the basic logical relations that we're going to have to think about, and just a very simple truth table. We're not trying to prove anything here, just look at all the different relationships between these letters. So I chose P and Q. It could be A and B, it could be X and Y, it could be any two letters that you want in the world to get started. This is when you have two letters and you're building a truth table. So we're going to start with our P and Q columns. You always start by giving two trues and two falses. And then in your second column, you alternate true, false, true, false. So if you have two letters, this is all you need. Every truth table is going to start just like this. True, true, false, false, true, false, true, false. And the reason that we do that is we want to get every possible combination of true and false. If P and Q are both true, you satisfy that right there. If they're both false, you satisfy that right there. P is true and Q is false, we have that. If P is false and Q is true, you have that. That's every possibility. So that's how we always start. And then we can look at all the different relationships. So not P, we have our little tilde and then we have a P, is going to be the negation of whatever P is. So you just put in the opposite. So if P is true, true, false, false, not P is going to be false, false, true, true. P or Q, you know our V stands for or. In philosophy we have what's called an inclusive or. What that means is if either one of P or Q is true, then P or Q is true. Or if they're both true, then P or Q is true. So for P or Q, we have P and Q are both true. Well, that means that one of them is true. So either the cat or the dog did it. Well, if either one of them did it, then it's true that either the cat or the dog did it. And if the cat and the dog teamed up and did it, it's still true that either the cat or the dog did it. P or Q, if P is true, then P or Q is true. P is false, Q is true, that's still going to be true. And finally, where they're both false, P or Q is false because neither one of them is true. So the P or the Q is going to be false. P and Q is going to be, look a little bit different. If I say, look, today is Tuesday and it's raining outside, that statement, that compound statement is only true if both of the parts are true. So for any and statement, the whole thing is true only if both P and Q are true. If P is true and Q is false, that whole thing is false. If P is false and Q is true, that whole thing is false. And of course, if they're both false, that whole thing is false. Our third one, if P then Q, that's our horseshoe relationship. Where they're both true, that's true. Where P is true and Q is false, that's false. Where P is false and Q is true, that's true. And where they're both false, that's true. This one is the least intuitive of them all, but I can explain it with an example like this. If Obama gets elected, that's P, then he'll lower taxes. In this case, Obama got elected and he lowered taxes. So the compound statement, if Obama gets elected, then he'll lower taxes, turns out to be true. In our second case, if Obama gets elected is true, but he didn't lower taxes, so it's false that if Obama got elected, then he'll lower taxes. Our third case, if Obama gets elected, then he'll lower taxes. It's false that we elected Obama, but taxes went down because the other guy did it. Well, it's still true for logic purposes that if Obama had gotten elected, then we would lower taxes. Now that's one that sounds a little bit weird, but we have to give it true or false. And since we never elected Obama in this scenario, we can't really blame him for not lowering taxes. And the fact that taxes went down anyway is a good reason to consider it true. And finally, if neither of these things happen, if we elected Obama, then we lower taxes. Well, we didn't elect him and taxes didn't go down. It's still true, potentially, that if we had elected him, taxes would go down. So we call that true. And you just have to kind of remember that one. It's not the most intuitive one, but that's the way we're going to break it down in logic. Our last relationship is the P triple bar Q. That means logically equivalent. P is logically equivalent to Q when they have the exact same value here. So they're both true, so it's true that they have the exact same value. Here we have a true and a false. Here we have a false and a true. In both of those cases, they don't match up, so those are both going to be false. And finally, we have false and false. Those do match up, so the P triple bar Q is going to be true when both P and Q are false. All right, so that's our basic logical relationships for all of our basic connectors. The not, the or, the and, the if, and the triple bar logically equivalent.